From the beginnings of mechanical invention, lubrication has been a necessity. This picture of ancient Egyptian industry shows the transport of building columns on rollers and sliding runners. Even then, engineers knew that lubrication made their task easier, and here is a workman pouring lubricant on one of the runners. Even ball bearings were known to the ancients. These once belonged to a Roman state ship. This 400-year-old mine truck was lubricated with wet clay, and this drawing of an old ironworks shows a spindle being lubricated and cooled with water. Fatty lubricants were known. Even raw bacon fat sometimes served to grease heavy bearings. Modern machinery calls for something better than the makeshifts we've been looking at. Great advances in engineering have gone hand in hand with the development of oil. Yet how many people could explain why lubrication is so vitally important? Here is a model of a simple bearing and shaft. The impression given is of two perfectly smooth surfaces in contact, able to slide one over the other with a minimum of friction. But appearances are deceptive, as the microscope proves. Though this surface has been finely ground and honed, countless minute irregularities remain. Imagine two such surfaces rubbing together. Naturally, only the peaks of the irregularities meet. Consequently, they grind harshly together, and particles break off, scattering through the bearings. Fierce dry friction is set up, with retarded movement, rising heat, and loss of power. The metal expands due to the heat, and the whole bearing seizes up or even melts. There you have a problem that only oil will solve. Lubricating oil of the right quality fed into the bearing literally forms a cushion on which the metal surface may rest. When oil is introduced in the correct quantity, a copious unbroken film keeps the surfaces well apart. Methods of distributing oil are important. The old-fashioned oil groove idea was abandoned when it was found that the grooves allowed the oil to escape from the zones where it was most needed. Nowadays, oil is distributed by means of oil pockets. Narrow tapered cavities are cut into the sides of bearings. In these, the oil collects to be picked up and carried round by the shaft, which is thus liberally coated with oil all the time it turns. When the shaft slows down, the oil drains off into the pockets, ready to be picked up again when it restarts. Plane surfaces are a separate problem. If the edge of a plane surface be correctly beveled, its motion will create a wedge of oil at the forward end, which lifts the moving metal, permitting it to ride along raft fashion. This is exemplified by the aquaplane, a wedge of water exerting a similar lifting effect. The machines that serve our needs must have oil, whether it be a few drops a year or many hundreds of gallons. Lubrication is the lifeblood of modern transport. With the advance of oil research, speed and efficiency move steadily forward. Proper lubrication makes it possible for the Flying Scotsman to cover the journey from London to Edinburgh at a speed of over 60 miles an hour. The air has been conquered on oil. Only the highest standard of lubrication makes such engines as this possible. Airliners like Canopus are able to bring world travel within the scope of a few days.